Oh, I can't tell if it has started, but I assume it has. Let's call it, we're going to say physical science time.
Yeah, it's
Physical science time. You all say it.
physical
science time. And now, good, I like how creepy it is. The objective is describe motion in scientific terms. So please write that down. Describe motion in scientific terms. This year, I have left this objective vague enough that, it's specific enough that we're going to get some work done, but it's not so specific as to narrow itself down to one of these lessons. So this objective will apply for all three of these lessons. The objective is describe motion in scientific terms. You will have an assignment this evening. I'm not going to assign it yet because otherwise that's all you'll be writing down. Here's our unit conversion that we did just for some practice. Let's begin. So the first thing we're going to talk about here is, a good way to start. If we're describing motion in scientific terms, let's just define what motion is. Motion. Someone give me a definition that you're comfortable with for motion. You have done your vocab, so you know what the book says, but I want to hear a definition from your brain and your soul. Justice, give me your soul definition of motion.
objects moving.
Okay. I mean, really, if we're objects moving, let's be a little bit more specific than that. Can someone expand upon that? Or, I don't mean expand necessarily, but can someone be more specific, or perhaps without trying to punch Justice in the gut, can someone be more eloquent about it? This is like a caveman said it. No, not you, Justice. You already had your shot. Ashley.
An important part of describing the motion of an object.
It's just, we can't describe motion by saying the motion of an object, but it is an important part of it, and we'll talk about in a second what that is.
Object like moving in a certain
An object moving, does it have to be circular?
No, I mean like in a certain direction.
Oh, certain direction. That does have another specific definition. What does it mean to be moving? Let's check over that. Maybe that's how we can make it more specific. What does it mean for an object to be moving?
It push or pull.
Force.
Okay, so a force might be acting on it. We'll talk in a little while, it won't be today, but we'll talk in a little while in this chapter about how not every object that is moving has a force acting on it, but perhaps, so not necessarily that. What does moving mean? How can you tell something moved? How can you tell that I have moved this morning?
Because I can just see with my eyes.
Because I can look at your feet and see that your feet are
So
moving.
to some extent you can see my moving, but how do you know that?
Not necessarily.
Because
Exactly. Okay, let's go with Alexines. Exactly.
Okay.
So something I have done what? My what has changed?
Where you're at.
There's a better way to say where you're at. She's right, but there's a better way to say
Position.
yes. Changing position. Let's just make that clear. Changing position, and then further we'll go even deeper. What is position? What's another way we can say position?
Standing point.
Okay. Point in space. Yep. Location. So if the point in space an object is at, or its location changes, its position has changed, and if that happens, then it has moved. Motion is when an object has changed position.
That's crazy.
You know what? That's crazy. What was my position starting out on September 9th, probably?
You were outside.
I was in my bed at my house.
Oh.
And now I'm here. So even if you didn't watch me, even if I'm standing completely still, let's say Mr. O. I don't think I've seen Mr. O today. But even if I'm standing completely still, and Mr. O comes in here, he will understand that I have moved, because the last time he saw me, I wasn't right here. You see what I mean?
Yep.
Since my position has changed from the last time he saw me, he knows I have moved at some point.
That's crazy.
Those are some nice shoes.
Thanks, John. Okay, let's talk now about this other idea of, I'm going to try to see if I can drum these out of you. We need to have there are three criteria. We need to have these three things for describing there, we'll make it look fancy instead of like I made a mistake. Three criteria for describing motion. How many do you think they're going to be? Nice.
3.
If we're going to be, I'm blocking it, scientific in our description of motion, we need to have these three things. Two that we've already mentioned actually when you were trying to describe what motion is. Actually, what was one thing we need to describe motion? If I want to be, let me rephrase it. If I want to be specific. For my example, if Mr. O wants to know how far I have moved from the last place he saw me, let's just pretend the last place Mr. O saw me was at my desk. And if he wants to be specific in describing to someone, maybe he's writing an email to Mr. Lovercheck about where Mr. Kime has gone, and I'm here now. I was there the last time he saw me, and now I'm here. How could he specifically, in an email, so Mr. Lovercheck, he's not taking a video or anything, how could he write an email so Mr. Lovercheck knows exactly where I am?
You are in.
No, okay, so I need to have... So what? So pretend I was over there, I was over at my desk, and now I'm here. How is he going to exactly describe where I am to Mr. Lovercheck in the email? He needs to have 3 things, and they are what?
How fast you're going, so like speed.
Does he need to know how fast I went from here to there? I mean, it might have taken me all night, it might have taken me 2 seconds, but could he describe where I am without talking about how fast?
Yeah.
Yes, so what does he need to know though? How, not how fast, but you're almost there.
Where?
Okay, so where I was, which we call a reference point. We need to have some reference point, and this is, let's describe it this way. A reference point is a object we compare another object's position. Oh wait, an object, let's put it this way, to which, sorry, I don't like to end the sentence with a preposition. The people generally agree that that's not a sin anymore. When I was taught that way, that's how we did it. An object to which we compare another object's position. If you almost say it like a crawdad person, object we compare another object's position to is fine. And really that's becoming more acceptable, but I still don't like to do it. An object to which we compare another object's position. Or an object we compare another object's position to. Either is fine with me, you won't lose points. I mean, you won't lose points on your grade. I will have a lower opinion of you. Just kidding. Thanks for laughing. Okay, so the reference point, we need to have a way to describe something in relation to where I am. And we use that word a lot. In relation. Or relative. Oops. So I might say something like, in relation to this ceiling tile, I am what? Under it. I'm under it. Yeah. In relation to the ceiling tile, I'm under it. Okay. So we have a reference point. We have some object to which we are comparing the motion, the observed motion that I had. What else do we need to know? If to describe specifically exactly where I am in his email, he needs to tell Mr. Lovercheck what.
Where you are at now.
Right, that's what we're going for. That's the whole goal. Someone over here said it though. The what from the reference. Yeah, the distance. The distance.
I pretty much said that. I pretty much like
the distance from the reference point. So he might say, I'm 4.5 meters, maybe a little bit more, 4.5 or 5 meters from the reference point, which is where he saw me last time, my desk. Okay. Now think about it. If all he has told Mr. Lovercheck is 4.5 meters from Mr. Kime's desk, is that going to cut it?
No.
No, because where else could it be?
Over there.
It could be in the corner. So he also needs to tell the direction. There we go. Now we got all of them.
You're in the
Direction.
southwest corner.
Am I?
Yes,
Yes,
you are.
I am. Yeah. So I've gone. We'll say it's southwest. It probably isn't exactly.
It's not
If
exactly.
we wanted to be more specific, we could say something like 10 degrees south of west or something. But we're not going to do that.
Maybe 10
But listen. The direction southwest is a direction. So he could say, Mr. Kime has moved 5 meters distance southwest direction of his desk, the reference point. And that would tell him exactly where I am. You see what I mean? So in order to exactly describe an object's motion, how it has moved, we talk about a reference point, a distance, and a direction. Which one of these things has a unit with which we measure it? Usually distance. We could also, like I said, we could measure direction with degrees, but distance we use a unit for usually. We have to have all of them. Because if you don't have, for instance, if you don't have the direction, this motion is encompassing anywhere within a circle of that distance from that reference point. If you don't have a reference point, it's completely useless. However, now listen, if I just say, if I called Rhett on the phone and said, "Oh, I'm 2 miles away," What does he understand the reference point to be?
You are
2 miles away from what? From whoever I'm talking to, yeah. If I say I'm 2 miles away, he assumes that the reference point is him. If we're already talking about Walmart earlier and I say I'm 2 miles away, the reference point would be Walmart. You use the reference point in conversation. Not no one. Some of us are dorks. Not no one, but no one usually says, the reference point I'm using is the flagstaff. I am 10 feet away from the flagstaff. You just understand the reference point from the rest of the conversation, okay? Your book also calls this, let me write this down just to be clear. The book also calls this frame of reference. We've got 4 kind of words or phrases that we use for this thing. These are the usual, in science when we're being very specific, we use these 2 kind of code words, in relation or relative, but both of those are talking about frame of reference or reference point. They mean the same thing, or at least at this level they mean the same thing.
so.
Questions about this so far?
Nope.
Let's try it out. Let's describe the position. Oh, this could also be, sorry, I should write this down. Motion or just the position. The whole thing can be used for describing just position too. If we're comparing 2 different positions, then that would describe motion. But it also just describes one plain old position. Let's describe where, this will be what your bell work is like tomorrow. Where is Justice relative to Angie?
About like 7 feet.
So west.
That's north.
That's
6 meters.
north.
Yeah, I would guess probably about 3 or 4 meters north of Angie. In that little sentence that I just said, we have all these things. 3 or 4 meters north of Angie.
I said 3.
So where is Angie relative to Justice?
Same thing, but the opposite
Yeah,
direction.
3 or 4 meters south of Justice. Okay? So make sure you're using all 3 of those things when you describe position. Good? Questions about how we describe position, which is also how we describe motion.
No.
Are you sure? Okay,
How am I relative to the door?
You're like a meter away.
he's probably like 2 or 3 meters
From which
east, right? Of good, yeah. Of the door to Mr. Kine's classroom. Crawford, Nebraska 619. Okay, next thing we're going to talk about is, let's write this down. Let's do it in a different color. And I'm doing this for a couple reasons. 1, because I want to. 2, because I want to see if it shows up on the camera. Displacement.
Here, I'll check.
No, it's okay. Hold on. I'll look at the video later. I'll look at the video later and weep. Okay, displacement. This is, and keep this separate, this is a vocab word, but I think it needs a little bit more explanation. In general, in this book, I would say that, I expect you to have all the vocab in your little brain, but we'll talk about, I would guess, roughly 40 to 50% of the vocab in more depth, because I think it's slightly more difficult to understand than just the description the book is. So displacement is this idea where distance, I'm going to bring that down here, distance is how far an object, we're going to use that word a lot this year, has traveled. And displacement, contrary to that, displacement is how far an object is from where it started. And we're going to talk about the difference between those 2 things because it is extremely important. So distance is how far an object has traveled, and displacement is how far an object is from where it started. Because I just told you this should be an easy answer, is there a difference between those 2 things?
Yes.
Yeah, there is. Can you think of a time where something's distance that it has traveled and displacement would be the same?
Miles per, like, just like.
We're going to have to have like a little anecdote. Like what, in what circumstance? Possibly. So, okay, there we go. Thank you. So if we had crawdad right here. Okay, I can't use C because Shadron also starts with C. Crawdad right here. and we just drive in a straight line, you can't really, but pretend we're driving a straight line to Shadron, we have a distance traveled of 22-ish miles. Okay? So the distance we've traveled is 22 miles. Distance. What's the displacement? How far are we from where we started? 22 miles. 22 miles is also the displacement. So can they be the same?
Yes.
They can be the same. Why am I emphasizing can?
Because
They're not always the same. Now think about this. You get done doing your grubby little business in Shadron, and you drive back to Crawford. Now, how far have you traveled? What's your distance?
44.
Yeah, distance equals 44 miles. What is your displacement? How far are you from where you started?
22.
No, from where you started, the whole thing.
0.
0. Displacement in this case is 0. Because you're right back where you started. Displacement is 0. Okay, now here, just a little side note. What was my unit for displacement? It was, I don't have a unit. 0 doesn't have a unit. Let's just write that here, side note. 0 has no unit. Sometimes if we're trying to be real specific, or if we have two different kinds of sets of data and we want to make sure that we're talking about one and not the other, we sometimes label it, but it doesn't have to have a unit. 0 is 0. 0 has no unit. Because see, if it's 0, it doesn't matter if we measured in miles or centimeters or inches, they're all the same. Do you see what I mean?
Yeah.
Okay. So, are you all clear about distance and displacement? So the distance is how far I've gone. So, what's the distance between these two things? Well, it depends on the path I take. If the distance is how far I've traveled here, and I'm traveling all in squiggly little lines, the distance might be great. But the displacement is still just how far away it is. And even worse, if I go like this, squiggle, 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 and then I get right back where I started, my displacement is 0. Okay? So the displacement is just the straight line path, kind of like as the crow flies, how far it is from where we started. Whereas the distance is the path we took, the length of the path we took. Okay? A couple more things here. How do we measure motion, you reckon? Raven, would you be quiet, please? How do we measure motion? So we know how we can find motion. We just talked about that. But how do we measure it?
Well, it matters on the distance.
Okay.
It really, so say they're trying to measure from here, Shadron, they might use something a lot bigger than a ruler. If they're going to use something bigger than a ruler, like if we were measuring from table to table in here, we might use one, but
meter thick.
Yes, that's how Colin is correct about. That's how we measure distance and displacement. That's how we measure it. But how do we measure motion?
Distance and time.
Distance and time. Why do we need time, Ashley?
Because I don't know how to explain it.
I think I can explain that.
Okay, Colin, let's hear it.
How I wrote it down for when we were talking about that is motion is an object's moving or change of position, and the point, if you're in that point, your motion depends on where you go.
Yes? So it depends on my displacement.
Yeah.
It also depends on my time, as Ashley says, because, why? Yes, okay, there we go. So motion, we measure motion with, measured with speed. And speed depends on distance and time. If it takes me a long time to get from a certain distance, let's say I'm talking about my desk again, 4 or 5 meters. If it takes me a long time, great big time, is that a fast or slow speed? Slow. So time and speed are inversely proportional. Sorry about that. Time and speed are inversely proportional. Have we talked about inversely proportional at all? I think last year we did a little, but we're going to talk about it real quick here. Inversely proportional, this we use all the dang time. It's one of your CCCs. Look up there. See the orange one with the elephant? It says scale, proportion, and quantity? You see it?
Yeah.
CCC once again stands for cross-cutting concepts, remember? So they cut across all the sciences. In all the sciences, in every one of my classes, I talk about inversely and directly proportional. Inversely proportional means as one quantity increases, the other decreases. Right. So in this case, speed and time, the longer it takes, the lower the speed. They're inversely proportional. As one goes up, the other goes down, and vice versa. Inversely proportional. What about distance and speed? If it takes me, imagine it takes me the same amount of time. If I go a further distance, have I gone faster or slower? Further distance,
So
faster.
distance and less time, so you're going faster.
Yep, further distance in the same amount of time is faster. And so distance and speed are, distance and speed are directly proportional. And we're going to define that real quick because we'll use it all year too. Directly proportional. And this means as one quantity increases, the other also does. And I'm going to rewrite my Q because it's not very good. There we go. So let's think of a little math. There's an equation. What equation could we use for this thing? Oh yeah, go ahead.
So when you said that as one quantity increases, the other does. So say I'm going 100 miles an hour to Shattuck. No matter what, the distance would be the same, wouldn't it?
You mean, okay, let's imagine you're driving for an hour, so your time stays the same. If you go 30 miles in 1 hour, you've gone 30 miles an hour. If you go 100 miles, which is a greater distance, in 1 hour, the time is the same, then you've gone at a faster speed, 100 miles per hour. You see what I mean?
Okay,
So
yeah.
the distance has gone up?
The distance from point A to point B.
No,
not the distance
no,
that
not
you travel.
necessarily.
My bad.
Yep. So how can we express this mathematically then? What mathematical operation could be done to these things?
We're
We're going to have an equation. We're going to have an equation. What mathematical operation should these things do? If one's directly proportional to speed and the other is inversely proportional, what mathematical operation does that imply?
I would say conversions because that's what we
But I'm thinking about the four mathematical operations.
Yeah.
Which one would it be? If one is directly proportional to speed and the other is inversely proportional, what mathematical operation should be between them? Division. So we know that we're going to have distance divided by time, and in this case, speed equals distance divided by time. So this will be the last thing before we go. We'll continue this tomorrow. I've given you the equation. You must have this memorized, and you must, every single time we have an equation like this, we're going to write it down like this. S is speed.
So, hold on.
No,
So
wait.
we're writing this like we did with the row?
Yep, this is just like what we did with density. Rho equals m over v. Lowercase d is distance, and lowercase t is time. With what unit in the SI, what base unit in the SI do we measure distance?
Row.
No. What unit?
Oh.
Meters.
Meters. The base unit in the SI for distance is meters. What base unit in the SI do we measure time?
Seconds.
Seconds. So then if my equation is distance, measured in meters, divided by time, measured in second, what's my unit for speed going to be?
Distance over. Meters over second.
Meters per second. Meters over second, which we pronounce as meters per second. And this reminds you of the rate conversions we did. Remember, all those speeds were always something per something else. Let's do a practice one real quick. Who wants to be in the example problem before we have to go?
I do.
Justice.
Oh man.
Rat King oozes, there we go, across his lair, which is 3.1 meters. It's a big lair for a rat. 3.1 meters over the course of 27.3 seconds. It's oozing.
Someone's gonna look back in my
How-
because like
How fast? How fast is not how we usually phrase it. We're kind of running out of time. First step. We talked about this with density, and you should know. No. What's the first step?
oh right the given.
Right the
Speed, right the given.
Distance.
No.
for equations it's different. Right the
Speed equals.
what's step one of doing it? Yeah, the equation, the raw equation. You have steps for this in your notebook. Write the raw equation. What's the raw equation?
Given.
Well, S equals D over T.
So write this. Everyone should be writing this. S equals D over T. What's step, okay, this is step 1, write the raw equation. What's step 1.5 if we need it? We don't in this case, but if we needed to, we would. Remember, we had a whole thing, it was something.
I know. What was it?
It was equation station, what in tarnation? You remember that? Equation?
Oh, yeah.
Yeah, I literally have tarnation in here.
Yeah.
Oh my gosh, I have
Equation.
that.
I hate it.
What do we call it? If we need to do it, we...
Equation.
Conversion faction.
No.
No.
Conversion faction.
It was manipulation.
Yeah, manipulation. Yes.
We don't need to do it for this one because this is already set up to solve for speed.
Equation manipulation station, what in tarnation?
Exactly.
Yeah.
So this is already set up to solve for speed. We're trying to solve for speed, so we don't need to manipulate. What's step 2?
Fill in the
No, not fill in. What's the verb we use? You're right,
Equation
but
manipulation.
no.
Put in the unit.
What's the verb we use when we fill in?
I know what
Substitute.
it is.
Substitute with units. So we write in our distance 3.1 meters. Shh, write this down, please. We write in our time 27.3 seconds. Now, step 3, solve. 3.1 divided by 27.3. Calculator. Calculator, boys.
Calculator. What are we doing? 3.1 divided by
That's nice.
27.3. 3.1 divided by 27.3.
Mhm.
0.11.
0.11. Wait. 0.11, but now we need to divide the units. Meters divided per seconds is meters per second. Check it for reasonability.
It's very slow.
About 10 centimeters a second. That seems right for the Rat King. You have questions about any of this?
No, sir.
Okay.
Yes, I'm 1.